Judy-Anne.
Thank you very much, Don, and thank you. I'm super delighted to be here. Hello to everyone online. Hello to everyone here. Thank you for the organisers for the effort and graciousness of organising a lot of conferences. I know the work that it takes. I also acknowledge this place, the history of this place, the knowledge systems of this place, the ones that go back tens of thousands of years, the ones involved in building the university, and very especially the people who work in the intersection, which can be really fraught. So super happy to be here. I want to tell you about the CARMA Matrix Art Awards and announce the award this year, and encourage you to participate, or encourage your students to participate and see value in it. And here we go. So CARMA Matrix poster competition started when Rita Agrawal, PhD student at CARMA, came and said, you know, I've taken off my engineering and maths is never anything fun. The engineers get to do fun stuff. Can't we do something fun, please? Something. And so, you know, too busy, but you can't. And we're putting in so much energy. So really huge shout out to Rita, who really instigated this. If you want to have a look, the CARMA.org, probably over there, you'll find about the art competition. Matrix joined in 2022, so super pleased to be in collaboration with Matrix, which is a really important part of our mathematical community as well. And there's now a physical exhibition and Matrix of the prizes. So we even made it to the Credit News with an article about the awards from last year and some of the displays of the beautiful artwork from last year, and an article about Matrix and the great yards. We're so gracious in coming together about these prizes. So let's get right into it. I know some people are joining from afar. This is clashing with their lunch. Let's have a look at some art entries. It's going to be about 20 or so. Landscape, dark mountains. So some of these, you're not restricted to one entry if you're an entrant. So you can see some families of entries here. Dark mountains, the artist's statement is this is a fractal landscape arising in the basin of attraction of a Lorentz-like chaotic dynamical system. Here is this depth and darkness, but change your colours, and it's an island. And change your colours, it's a fire. And change your colours, and it's a forest. Maybe a real forest. Could be an issue this coming summer, given all the rain and growth and all the heat that is predicted. So there's a bunch of entries arranged around those Lorentz-like chaotic dynamical systems. Here's some more dynamical systems. This is the beauty of the Lorentz attractor. The artist statement says the most famous strange attractors, undoubtedly the Lorentz attractor, a three-dimensional object whose body plan resembles a butterfly or a mask. And we will put up these artist statements on the CARMA website, and there the artist statement has a link to a place. You can go and play this in a 3D version and I'll tell you the mountains like that. Pretty cool. Then we go into complex numbers, the beautiful patterns of blush hue products. This entry says domain colouring is a method that allows us to represent complex functions by assigning a colour to each point of the complex plane. Because, you know, complex numbers are annoying, right? 2 by 2, this is 4, this is bigger than 3. How do you graph it? You graph it with colour and magic.
Is this an academic at University of Queensland, by the way?
I don't remember, but we can go on to the website and pull the names up pretty soon. Didn't want to preempt the awards, but there are things, and it's also a calendar. Does anyone remember the name of the calendar? It comes out every called Complex Beauties, and that's got people from all over the world contributing this kind of artwork coming out of complex numbers. So, and there's some for several years running back. So if you look up complex beauties, you can find many more beautiful things like this. And there is also a link at dynamicmath.xyz where you can play with the beautiful math. Recursion, randomness, and nature. Oh, very beautiful trees. The other statement says, with the power of recursion, randomness, and affluent transformations, it's more linear algebra, it is possible to create beautiful trees. Make your own here. So there's a www.geogebra.org/classroom/link, which you can find on the CARMA website if you want to play some more with growing trees. Just in the very, very regular thing, but that recursion that we love, a little bit of maths display, from a little bit of randomness coming along as well. Involution curve is this one. The other statement, involution curve first appeared in Reynard Quispel's Libor and Moricum. At the time, not much was known about involution curves. The starting point is a double base point of the quartic pencil of curves. This is a point that is visited twice by every curve and can be used to define an involution. That's a map that brings you back to where you came from, which is what I really like. I've just moved home from having gone away a long time ago, and I like coming back to where I came from. Beautiful little map like ones. So like, multiplying by -1. Let's go somewhere else. Again, let's come back. The involution. A map which brings you back to where you came from if applied twice. By birational transformation, each quartic curve was put into Weierstrass form, which is a cubic curve, and the involution defined by double base point becomes an involution with an involution curve. And this intersects with each Weierstrass curve in a different involution point which moves from curve to curve. So high-old involution curve. With all of that weird stuff going on, it's that symmetry that we love so much, like a mountain over a lake in the reflection. Something very human to respond to these things. This one's got a cool name. Hexagram mysticum. And what's going on here? Blaise Pascal, you know, famous probability guy, French mathematician, physicist, inventor, philosopher, writer, theologian, child prodigy. Probably also worked really hard, because we don't mention that. We mention brilliant people, but we don't mention the time they was 16-year-old when he discovered about this creation here. And there's conic sections and there's intersection points and there's a line. This one, which is Pascal, and it's actually on the side. And isn't that amazing when you see that and feel that in a different way into the maths? And I was thinking in one of the earlier talks, we're talking about, you know, pre-exposure to stuff. One of the things we want from pre-exposure to stuff, I think, is pre-exposure to a feeling. That feels right. No? As opposed to, I read that on line 237 of page 632 of the textbook by, I don't know, Stewart or whatever it is. Consideration. It's a nice contemplative sort of a title here. This one says, consideration is dedicated to my father, whose approach to life and art is quite considerate. The theory of Lagrange multipliers has been used to find 3 concentric circles that touch a parabola. One of them is combined colour-wise with a parabola. Together they form a quartic curve, the closed part of which is on the inside. Most considerations are internal, but their manifestation will be presented. That's like the sort of thing you play with GeoGebra and stuff as well. And now there must be another stuff going on here because they've got ladder double functions. And I've heard number theorists mention that phrase. I don't know what a ladder W function is, but I know they're number theorists. And here we've got a window. We overlook the graph of the exponential function with a disk in the foreground. The point where they touch the point on the exponential function is closest to the centre of the disk. In mathematics, the exponential function as well as the trig functions are called elementary functions. The lambda W function is a special function. That means we can't express the function in terms of elementary functions. That is, there's something beyond sine and trig, you know, sine and cos and x. Who knew? The x-coordinate of the touching point is given by some formula. Minus half the value of the lambda W function is 2, and this defines a function and a large rectangle that fits in a quadrant of the curve, which is twice as high, happens to have some really pretty patterns going on. And there's different ways of pretty patterns. One of the ways of pretty patterns is formulas, and they're amazing. So it's, simulating the computer, the pictures are another. You're going, what are the colours on this? More land W windows and more curves swirling around in an interesting way. But this time the artist statement says degenerate pencil does not support the ideals of pure geometry and contemporary tendencies such as application of the result of political influence. That's interesting. Relates to what we were and moral climate universities. This is very, very interesting given the talk we've just had.
All that in one picture.
There's comments about birationally isomorphic to the projective line and Manon transformations and a degenerate Manon transformation. And indeed, each curve in this cubic pencil shares a singular point and hence their genesis reduced to zero. They're not elliptic curves. Elliptic curves aren't made as full, but they are full. And now we jump to something different, something physical. A 3D model of the ring surface of the square root function. So accurate. It's made from copper and sulfur by my father, says the artist. And he's designed the model as a DIY project, which comprises 17 planar parabolas together with an instruction how to put them together. There's a description of the formula, which would be tedious for me to read out. The first equation tells us we're dealing with parabolas, the second shows that planar curves, and the 15 fixed values for Q are chosen so that the curves are equidistant at x equals z equals 0. Oh, the shadows, interesting. Yeah. Not infinitely far, but infinitely. Given 6 points and a 7th, there is a unique curve which contains 6 points and is singular at the 7th, with an 8th point is chosen to be on that curve, the 9th, aka the Cayley-Baccarat point, is infinitely near the 7th. It can be seen that the 9th point is infinitely near the 7th, as all the curves from the pencil are tangent there. I think you can stare at that for a pretty long time, still getting stuff out of that. And let's shy back from infinity for a bit. Or a different kind of infinity. Well, probably balance piece of something there. And I've got to be conscious of the time. So I will just note that this is related to initial value problems, which come in 4 flavors: underdetermined, overdetermined, nearly well closed, and well closed. And we're talking about what well closed means in this context. And then let's change again and go physical. 3 pieces of paper and sticky tape. The complex sine function is a many-to-one function, and its domain has been squeezed and glued in this interesting way. Rise and fall the rainbow. Level sets of an asymmetric cubic polynomial are reminded that the world goes round and opposite forces interrelate. Hope is rising and tears are in the same basket. Worth reading the artist statements. If you go on the website, don't just look at the pictures. This is the Apollonian sunset, an Apollonian gasket superimposed over a synth wave sunset. And then the last one of the art entries, the 3 halves P cone in 4 dimensions. In mathematical optimization, we use error bounds to make larger problems computable within allowable time horizons. This image illustrates the error bound architecture for a 4-dimensional tonic linear programming problem. Just a bunch of numbers, you can see stuff. So, got to do the prizes. In 3rd place, the beautiful patterns of flashy products. By there's the name.
He's at the University of Queensland.
Oh, hello, congratulations. And the judges comment a very vibrant, impactful artwork with a clear focal point. Colour choices are bold, balanced, excellent use of canvas space and contrast with the sharp and blurred lines. We had both artist artists who are not necessarily mathsy and maths artists judging this, and you can see it in the comments. So congratulations to second prize, Holly Sunset by Travis Stenberg. Artist, The judge's comment, a beautiful use of colour and artistic arrangement to suggest a celestial environment. The variations in size and density of these shapes create isolated textures within the composition and layers of interest. Some of these things that we are coming directly out of our mathematics, but artists have the eyes to see it that we may not, the classically trained artists as well as the mathematical artists. So congratulations. First prize, Involution Curve by Judy-Anne. And the judges say hypnotic line work that creates a sense of depth within the image, adding interest and focus, beautiful aesthetics and movement with a fantastic colour palette that includes contrast as well as harmony. So congratulations, Peter. That is the bulk of the awards. We have just 2 entries for outreach, so I'm going to give you the entries as prizes spoken one. And next year, more entries, please, people, if you wish, if you see the value. Second prize by Rahel Balani, Fractals, Understanding the Geometry of Nature. And let you appreciate, you know, those trees we're looking at before, and there's the geometry, and there's the barley, you know, there's more trees that are grown, whole lot of gorgeous there. So congratulations to Travis Stenberg for that lovely outreach poster entry. And the first prize in the outreach entry was the judges were really high, but the school students involved were overwhelmingly in favour of first prize by Travis Stenberg, Turing Cards. And I think they had never seen anything like that. It's beautiful and they loved it. So congratulations to Travis Stenberg. And thank you to the artists, and thank you to the judges, and thank you to the CARMA and Matrix people who make it happen, especially David Allingham and Tom Keegan, who are so much more technical support, but who are also inspiration and make these things happen in so many ways. And to all of you, and if you wish, looking forward to your entries next year. That's it.